let's get started. We have our panelists for the day. Let me first introduce myself. My name is Sundar. I'm part of the marketing team at Murf, and I'm going to be the moderator for the discussion today. We're going to talk a lot about voice agents. We're going to get into the weeds, not just what is working, but what are the specific decisions, trade-offs, and practical lessons that probably separate a voice agent that does great in demos and something that actually delivers results in production. So that's the gap that we're going to cover today. And we have two incredibly qualified people to do that in the webinar today. And let me introduce you to the panelists and where they are from. First up, we have Patrick, who heads product at Agora. Agora, as many of you might know, is a global leader in real time engagement infrastructure. Agora powers voice and video for developers building at scale, and we're talking close to 80 billion minutes of communication every month, and that's huge. Patrick has been at the forefront of real-time audio for years. He's also worked with Polycom and Dolby in the past, and is now deep in the engine that powers conversational AI. He's seen voice and audio from pretty much every angle, and that's the expertise I'm keen to dig into today. And thanks a lot, Patrick, for making time for this and for joining us today. Um, Next up, we have Sahil. Sahil also is from Murf AI. He heads product at Murf. And Murf is an AI voice platform with over 10 million users across 195 countries. And Murf builds some of the fastest text-to-speech APIs for voice agents. Sahil also brings nearly a decade of product experience at Amazon across specifically Alexa and Amazon Robotics. And at Murf, Sahil is now focused on building the next generation of enterprise voice AI. So, Patrick and Sahil, a very warm welcome to both of you again, and I hope we have a great conversation today. Uh, Before we start off, just some ground rules. So, for the audience, if you have read our event description, we will structure this as a conversation, as a slow, deep conversation. I'll be the moderator asking questions to Patrick and Sahil. It will be around 30 minutes of conversation, followed by we open the floor for audiences to ask any questions. So if you have any questions, please note them down, post them in the questions tab that you see below. Questions tab is simpler because things tend to get lost in the chat tab. And we will take all questions at the end of this session. We'll keep some time for this and we'll get to that. So let's get started and let's get into it. And let's start probably with the bigger picture. And this question is to both of you, Patrick and Sahil. And probably we could start with Patrick. Let us start with the good news. So, where are voice agents actually working today? Where do you see them working today? And which use cases are you seeing genuinely prove out, Patrick?
Thanks, Sundar. So I think there's a couple of key areas. And the key theme is where things are a bit more focused and transactional. And so on the outbound types of calling use cases for voice agents, we're seeing success in the areas of sales prospecting that's very targeted to generate leads. Also in the area of surveys and things like election polling, right? And qualifying and asking questions before an election happens. One other case is around targeted debt collection as well on the outbound side. On the inbound side, it's really more about focused use cases in customer support and service. And typically those are going to be focused on mostly level 1 and level 2 types of questions with the ability to do a warm transfer to a human agent where that's needed. Then the last one that's emerging that we'll talk about a bit more, but gaining momentum is physical AI, so and embodied AI.
Great. Physical AI is something that I also want to hear a lot about, and we'll get to it a bit later in the session, Patrick. But that's a great way to set up this session: sales prospects, debt collection. Are there any other use cases, Sahil, that you are seeing apart from these that you think are picking up? And why do you think those are the use cases that are getting picked up more and more?
I see financial services as a whole, I think, is very lean forward in adopting voice AI. We see a lot of interest from, there tend to be a lot of transactions over voice for these financial services companies, credit card operations, banking operations, transaction confirmation. So there's a number of these use cases that sort of come up. The common thread, as Patrick mentioned, is that it's relatively narrowly focused. It's relatively predictable. It has clear success metrics. Yeah, and it has to be a big part of a company's operation or their business, so that it sort of moves the needle for the organization.
Got it. Got it. That's great. And if these are some of the useful cases, or these are some of the cases where voice agents are being deployed, when they get to scale, now let's get to an honest question. When they get to scale, what is still not solved? What is still broken? And we could probably start with Sahil. I see a smile on your face. Maybe we start with you, and then look at what's actually broken, and then get to Patrick.
Yeah, I think the time to create a jaw-dropping demo can now be measured in minutes, because you can come up with sort of a happy path use case which really knocks socks off of a business customer or a decision maker. But there are still many, many limitations in both the underlying accuracy of the models as well as steerability of these LLMs. And so we're in the, it works in demos, but breaks in production stage. So there's a number of, use cases or edge cases that don't show up in the demos that people struggle with. So background noise, multiple speakers in the back, accented speech, specific proper nouns, names, places, unexpected turns when, the customer sort of does something unexpected. And so I think, that those are, they are common enough that you can't introduce something in production without ironing them out. And so you have to figure out how to find them and then, work around them. It doesn't necessarily work as well as we would want it to work.
Got it. Got it. Patrick, do you see the same set of problems? What other challenges
Sure. So
do you see?
definitely
What's
similar
broken
ones,
still?
and in some other areas. One is if you're building chained or stitched mode agents that as you start to really scale up into production, what you see is that you typically have multiple vendors in that chain, and being able to manage things like concurrency as you scale up, and be able to things like querying that and managing that, and being able to scale very quickly. So that's one area as you really scale up into production. I think another thing that can break is the consistency. Depending on the load, for example, if services are highly loaded, then there's variability in the performance and variability in inference time, and that can always bring down your experience. So being able to have great observability and know what's going on is really important when you're scaling into production. And then lastly, it's really basic stuff, but this is stuff that I've been dealing with for many years, which is the problems of environmental noise, background noise, background humans talking, and what you get also then when you get really bad network conditions and how things perform. So those are things that we see that can break. Right?
Got it. Got it. There seems to be two bunches of problems if I have to cluster it. One is the basic stuff, which is noise, which is sometimes multilinguality, and the other end there is the question of scale, and there's a question of concurrency and all of that. And given the challenges that exist, and Patrick, this question is for you. Having said that, how does the customer evolve, or what's the bar that they set to say that a voice agent is ready for production? Is there a way to define it?
Sure, and I think this heavily can depend on the customer as well. But what you do see is that basic things like the latency and turn taking have to work reliably well and fairly consistently to be able to deploy, and that's kind of the minimum bar if you're looking at this. But you may have some customers that have higher bars, right? In some of the physical AI use cases or use cases where people are looking at, they provided their IP, they also have certain guardrails for target audiences. How do you make sure that this is always resembling and on brand for the experience that you want to deliver? And so that may be a higher bar. And then you may have some customers that have a little bit lower bar, which is they're not constrained by human capital anymore. Let's say for these quick outbound engagements where they can learn more about their customer, they'd rather fail fast and forward, learn as much as they can as fast as they can, and they just need that minimum bar to be met to do it.
Understood. Got it. Got it. We spoke about a bunch of problems, and both of you listed some great problems, and we'll dive a little deeper into that later during the session. But if I had to force you to pick your top three challenges that you see, or top three problems that you think, if solved for, would really be great for voice agents in production, is there an order? And probably we could go with you first, Patrick.
Well, sure. I think that the first one is the consistency, as I mentioned before, consistency in performance in your deployment, so that you can know what you're going to get and be able to achieve the target business outcomes that you want, right? And being able to do that in scale. I think the next one is really dealing with those environmental and network conditions, because people are typically interacting with voice AI agents from anywhere on any device. And this can break when you're not in an ideal type of situation. I think the last one is really about cost to scale. As you scale into production, and it also depends by region how cost sensitive certain markets and use cases are.
Got it. And Sahil, building on that, what would be the order? What would be the top three for you?
I'd say these LLMs are still not as capable as they need to be. With voice, you have a very limited budget, latency budget, and so you can't fit the biggest LLMs there. And so the LLMs that you do get with that limited budget aren't quite there yet. They're still hard to steer. They require a lot of prompt engineering to get them to sort of perform the way you want. So I think that really slows things down. Second, I'd say that change management is hard. I've lost count of the number of customers who've come to me with the one pager saying, "Oh, this is the SOP." Like, this is not your SOP. There's, it's like a much larger document which is implied, but you haven't actually written it down. And so you have to sort of draw that out to be able to get the machine to do it correctly. And then the last one I'd say is that outside of English, speech recognition is still a bottleneck. It still gets 1 out of every 10, 1 out of every 15 words wrong. And that's just not acceptable if you're having conversations at scale.
Got it. Great. So consistency, latency, cost to scale, network conditions, multilinguality, and a bunch of other problems. And let's see if we can, in no order, double down into some of these problems. And probably let's start with something that's very basic and an expectation of voice agents, which is naturalness. And this is an interesting conversation because it keeps coming up. Earlier in our journey, when we were making voices, people wanted it to be non-robotic, then they wanted it to be natural, then you wanted emotional prosody, then expressiveness, conversational, add disfluencies, etc. Patrick, this question is for you. So when enterprises are building a voice agent, are they now asking for something very expressive, very conversational, or do they want something that's formal and works?
It really depends on the use case there. So let's say if you're using it, let's say for an outbound engagement like an AI SDR, then you're typically going to want that to be much more engaging, right, and expressive, and but also at the same time, you also need to understand and be able to look at sentiment of the human that you're engaging with, and be able to adapt that, for cases where this is important. I do think that in the future, the more data that you have about a person, and the more you can measure the sentiment, the more you can tailor this so it's much more personalized for that interaction. I think that's really where the next level is going to be.
Got it. Got it. And building on what Patrick said, Sahil, what does that mean for how you would approach voice design from a TTS perspective?
Yeah, and we've actually lived this journey. Murf started 5 years ago as a voiceover tool, and we realized that when we got into voice AI, we realized that the narration type voices that we had, which had great articulation, great expressiveness, they weren't what customers were looking for as part of a voice agent. So, and it starts right at the base of it. We train on conversational data now instead of read speech. So you need spoken speech, and so you need two people talking to each other in a manner that we are doing, as opposed to in the past when you would get actors to read out scripts. The amount of expressiveness is very different. When you have someone be happy or sad when they are doing a voiceover, the expectation is that they're acting, and there's a lot of you're being very true to the meaning of the word. with conversations, there tends to be less of that, especially in the professional context. You want, of course, to sound empathetic when the conversation demands it, but there is a limit to how much expressiveness you want in the voice. So, what that means for us is that we basically we have the same model and the same architecture that is optimized for voice AI, but we've got to start from the data that that is the type of data that people want to hear when they're talking to someone.
Got it. Got it. And naturalness or becomes even more complex when you factor in multilinguality. Sahil, you touched upon it a little while ago. Patrick, we've spoken about it in the past. It's not just about supporting a language, it's also about regional accents, variants, and getting that right. And beyond English, it becomes really challenging. Patrick, you've been doing a lot of work in markets like Latin America. So, how big a challenge is regional voice matching in production there? And what are some of the learnings that you might have that people who are deploying multilingual voice agents can take away?
Well, sure. I think that the region is very diverse, and so what you typically find is a lot of model vendors will pick a version of a language like Spanish, and then start with what is the most accent neutral and train their models on that, and then customers will then have to clone or build voice clones around that. So a couple ways these are applied. We have a customer that's, for example, a white label provider, and they work in many regions, right? Colombia, Chile, Peru, Mexico, and they need to be able to make outbound calls that are on brand for each of their customers. And when they're performing this outreach, you always have to connect in a regional accent that matches the destination that you're calling. So that has to be all set up. So all that is well and good, and all of that works. But what we found in production is that sometimes when you train that way on a core version of Spanish, like Colombian Spanish, and then you build voice clones, that the accent will drift, and you only find that by simulations and test calls. And this is something that really can degrade the performance of your campaign, for example. So this is a really important area that definitely has to be solved.
Got it. Got it. There's so many dialects and so many accents in the world that it's a challenge to get it right, and that's what makes it more relatable for an audience as well, right? And Sahil, there is a very different kind of, again, multilingual challenge that we see. There's another dimension to it in markets like India. You have code mixing, where typically a user who's speaking tends to mix words from other languages. Like if you're speaking English, you add a bit of Hindi, or you're speaking Hindi, you invariably tend to add a bit of English. So, which part of the stack does this affect the most, and how do you solve for it?
It affects all parts of the stack. Some of them are harder problems to solve than others. So the default assumption, if you're doing a voice agent in India, is that either English or Hindi plus some regional language, or English plus some regional language. That is the default that you have to be able to. You don't know what you're going to get. You, at some points, may also have to say that I'm going to be able to accept any of these 5 languages, and people will switch words between these 5 languages. Now, what that does is it makes all layers of the stack have to be robust to this. So the speech recognition models, the ASR models, need to be able to automatically identify which language it is. And what happens in speech recognition is that there is a trade-off in size of the model, speed, and the number of languages that it can hold. And so you're now sort of have this bunch of model builders who are racing to try to build models which can accurately recognize between Hindi, English, Tamil, Telugu. And so I think it's still very much a work in progress. We can offer some languages, but not all. In LLM, similarly, there's a big mismatch in the amount of training data that exists between English and the other regional languages. And so what we find is that if the LLM is producing speech in another language, it is often stilted or bookish or dated, because that's the stuff it's been trained on. So that's another problem that people are trying to solve. And then on the text-to-speech side, nothing turns off somebody more than having inauthentic accent. And so you could sort of, speak words from different languages, but if you butcher a word in a different language, that completely turns people off. And so the text-to-speech also needs to be robust to be able to say, okay, if this is the script, then this is how it should be pronounced. And so all parts of the stack, I think, are work in progress. We are much further along in TTS. We can actually tell the difference if the script is in the original script. It can sort of tell what the right way to pronounce it is. But if words are transliterated, for example, if you convert Hindi into English and then Tamil into English and you put those in, that is still quite buggy, because then the model has to say, oh, is this English English or is this Hindi in English? And then if it's something that's ambiguous, it may sort of make the wrong choice. So yeah, I think it's just a significantly more complex problem to solve if you have multiple languages.
Got it. Got it. So on one side, you have multilinguality, and let us switch gears to another factor which actually makes voice agents feel conversational, which is latency. And there are a lot of low latency models out there, but there's another challenge, and that latency is rarely ever stable. Sahil, this is for you. Latency in production, it keeps varying depending on load, geography, and multiple other conditions. So how do you bring this latency variance down? What have been your learnings?
We find that a lot of people actually don't measure latency correctly. When you're testing, you're sort of sending text to speech from your laptop up to the cloud, and then you're sort of getting a response back, and you're trying to measure that. It's not actually the right way to measure it. You have to measure server to server, which is where your voice agent will be hosted. So that requires a little bit of engineering, or you use a tool that exists. But essentially, we find that if you don't measure it correctly, you can't tell the difference between, because the hop from the computer to the server, to the cloud, actually adds a lot of variability, which you will not get in production. And so if you don't measure it correctly, you can't actually tell the difference between models that are providing you consistently good latency and models which are sort of inconsistent. And of course, there is a lot of variation in TP50, TP95, TP99. Some of the tricks that we've found is you've got to have lightweight models, which you can then provision enough infrastructure for and host them close enough to the place where the customer is going to be consuming them, so that there's not much lost in not much time lost in sort of network hops. But yeah, those are some of the things that we see on latency.
Got it. Got it. And Patrick, every hop in the voice agent stack adds latency. So while models will get faster and we wait for them to get faster, what are some practical techniques that you have seen to keep overall latency low today?
Well, sure. So I think that the first thing is you have to look at the region in which you're offering service. And also when you're, if you're building out a voice agent, a lot of voice agents still have a component where they connect to the traditional, telephony network or PSTN. So, where you need to do that also weighs in, because that leg itself can add a lot of latency. So what we're basically focused on is that, as you see initial deployments, they've happened cloud to cloud, right? And so you go from the speech to text provider to the LLM to the text to speech provider and then back. But what we're focusing on now is working closely with vendors where we can self-deploy those technologies on our network, put them together in what we call more of a super node, and then be able to spin up the resource for those, as well as the SIP to PSTN, or the PSTN to our network gateway, and that would then allow you for the ability to minimize the latency overall. There's also things like your CRM lookups, database lookups, with tool calls, and then in this case, it's a little bit more about perceived latency. To help out with that a little bit, you can use acknowledgement filler words or such approaches. So it's typically a combination of all these things that will improve the experience to the level that will provide the consistency for customers.
Got it. Great. That's some great practical techniques for people to apply who are probably facing a challenge with latency and have to wait for, instead of waiting for models to get faster. So let's look at another Uber dimension, which is something you touched upon earlier, Patrick, in some form, which is consistency depends on network conditions. We're talking here about reliability, and reliability in production is about making sure that an entire campaign does not fail if one provider in the stack goes down. So how do you build for that level of continuity?
Sure. So it's something we did from the very beginning. We have our software-defined real-time network. On top of that, we built what we call our conversational AI engine. And that engine is designed to work with multiple vendors and be able to support a great experience, regardless which vendors you choose. And so as you know, customers are actually requesting this now, that as they get into production, they don't want any one vendor's failure, maybe unplanned maintenance, what have you, to degrade the performance, and to be able to set certain criteria where you can switch to a backup vendor. Now, it sounds great in theory, but there are things you have to think about, right? If a service is in service, then out of service, and then keeps flopping up and down, you've got to have some sort of hysteresis or logic that will make sure that you get a good experience and stick with a vendor that's up. The next one is that when you look at these cases, that it's something to consider that a lot of customers, they actually clone a voice. Probably between 60 or more %, and then you see that if you do switch to a backup vendor, you better make sure that you've got a clone voice for that one too, so that your experience remains consistent in the one that you expect.
Got it. Interesting, and that's quite interesting to know. The other point that you touched upon earlier also, Patrick, is cost to scale. And different markets have very different cost expectations. So in a cost sensitive market, how do you think about the cost versus quality trade-off? And does the bar shift depending on how much a customer can pay?
So it's funny you say it, because some of our customers have actually told us that they're, because they really want to get the lowest cost to serve, that they're willing to accept a little more trade-off in less expressiveness and a bit more robotic to be able to satisfy a given use case. But that's one where you're typically replacing a service that maybe already like that, and you want maybe the benefits where you're scaling across multiple different services, and you want everything to be powered by the same underlying technology. I think the other key thing is to help lower the cost to serve. It's also about partnering with certain vendors, working with best in class, self-hosting, and then really aggregating volume with those optimal providers that can cover the range of dialects that you need and languages that you need. And that also helps to drive out cost. But it's a key focus area for us and for our customers. And so we really are looking at all the different ways that we can optimize this over time.
Got it. And Sahil, are there any practical things a builder can actually do to keep costs low without, hopefully, I know this is an ambition or a dream, but without sacrificing too much on quality? Is there a way to do that?
I think the first thing that's worth acknowledging is that costs are dropping dramatically. So if we, compared to where we were a year ago, I'd say, even our text to speech, the new Falcon model is 80% cheaper, something like that, in terms of inference. And the same thing has happened with these open source LLMs. For the same amount of intelligence, it's significantly cheaper. And so, costs are dropping dramatically. The reason people have a cost number in mind is because they are comparing it with, the alternate that might exist. In some of the lower cost countries, the alternate is lower cost. And so you say, oh, you have to hit this number. But I think it's safe to say that based on the sort of trajectory, there won't be that alternative cost will not likely be a constraint in a few quarters' time. We are sort of inventing a bunch of stuff, passing the cost back into the pricing, smaller models, cheaper chips, more efficient use of infrastructure. All of it is sort of getting put back in. And so the cost of these things is coming down quite rapidly. That being said, if you want to optimize for the here and now, whatever is the smallest, most efficient model that meets your need, more narrow, specific targeted use case, I think those are some of those tricks that people can do.
Got it. We've looked at cost, we looked at latency, we looked at multilinguality. Let's look at another point that comes up often when you work with enterprises and you want to scale in production, which is data sovereignty. So when you're deploying in different markets, especially for use cases across BFSI, where the data lives, where the inference happens, is also a key question. So, Patrick, this is for you. Customers in certain markets are asking for in-country hosting and local data residency. So how much does that constraint change the architecture of a voice agent deployment, and is that easy to execute?
Well, it's a very good question. So and when you look at the requirement around data sovereignty, it really depends on, sometimes it's regional and sometimes it's based on compliance for a certain standard, right? A good example might be HIPAA in the US. And so you really need to look at specifically what those requirements are from that given region or that given market and be able to deploy to meet those. The concept of this super node, or where you can spin up the resources where you need them, and then be able to control so that everything stays within a given region and you've got everything that you need to scale. That's really the kind of a fundamental architecture that lets you support that kind of thing. The other thing is that I think from the perspective of real-time communications, we've been doing this for quite a while in terms of working with larger customers to have private deployments where needed, as well as look at things like geofencing and where the data is stored. Those are problems that we've been working on for a long time already.
Got it. And Sahil, from the TTS side, is on-prem TTS at the same level as cloud today when a customer requires the data stay within certain borders?
Yes, but not everybody offers it. So theoretically, anyone who offered on-prem could take their TTS model, make it available. There are some risks to the model provider in terms of leakage and sort of intellectual property. And so it's something that people only do when you cross a particular threshold in size. But yes, the same TTS model that you're running in-house, you could make available for a customer. The trouble or the things that you have to watch out for is the infrastructure is not used as efficiently, and so the cost may end up being higher. With these models where you're spinning up a bunch of expensive GPUs, having the load balanced across multiple customers allows you to sort of leverage the chip, but you deploy it to someone who only has operations during the day. Then during the night the chip is underutilized, and so you've effectively double the cost of TTS. But it is a requirement for many industries, governments, PFSI, and so it certainly can be done. Yeah, people have just gated it behind higher price points.
Got it. That's interesting. So far we looked at how is the state of the market today, what are the challenges, how we can solve for it, and we dive deeper into some specific challenges. The next one is about the future, and that's why I like this section, and it's quite interesting. And Patrick, I was very interested to learn that you've been looking at physical AI, that Agora is looking at that. Where do you see that going? And that's a totally different use case.
Yeah, it's interesting that it's very much emerging, and we see all the right signs to show that there's a significant potential for adoption in physical AI devices for companionship, and in cases like elderly care. We were just recently at CES back in, it seems like a long time now, but just back in January, and we had about 10 different physical AI devices on our booth. And some of those were shipping coming up on the hundreds of Ks of units, and we're thinking of how do we project how this will take off. And very shortly, by end of Q1, some were already in the millions of units shipped. So really picking up fast. And what we're trying to look at with that is how do you make things go faster? So one thing that we came up with together with our partner RiseLink or Beacon is what we call the conversational AI device kit. I'll show it here. Let's see if I can get it into focus. There we go.
Yes.
So the idea here is that this device kit is almost like a Raspberry Pi for physical AI, where we partnered to build this reference design. All of the audio, video inputs and outputs are already tuned and optimized. It's got an audio chamber so that you could take this and leverage it inside a product and likely get to market much faster, in the order of about 6 months or less, to be able to deliver a solution. And to give you an idea of one thing that as a form factor that can be powered by such a kit, this is a Fazozo. It's let's see if I can get it powered on here. It's a cute little AI companion device. They're very popular in Asia with women about 18 to 25. This is one of those that's shipping very well and expanding into other regions. But the idea with these types of devices is that they are a companion. They can keep track of your daily diary. They can sing karaoke with you. They can basically maintain long context. And for this and providing that in a platform, we also partnered with a company called Sentino to be able to do that over time. But that's the idea of these companionship devices. You also are finding growth in entertainment types of use cases where people own the IP and they want to bring that to life in embodied or physical AI characters. So, we're also working on how do we accelerate that type of process with customers. So, in the technology side, it's also true that you want to be able to get to a predictable business cost. And so for that, some customers are also now looking at solutions where the speech to text and text to speech and more can happen on the device side. And that's of course also why we're talking with the team at Murf.
Got it. That's quite exciting, and thank you for showing some of the samples of products that you're trying to build, and it's quite interesting. And I just have a follow-up question there, which is, do you think like the model for voice agents or what the stack that powers voice agents differs across the two, whether it is a physical device or if it is in the form of a call?
It's today they're very similar because all of this is happening in the cloud. And there are the things with these types of devices, like how you deploy, provision, and manage them and update them. And we're also working with providers to make sure all of that is very easy, so that if you don't know anything about how to build a device like this, we can then provide. We have the whole ecosystem to be able to take that and start with your IP and help build the whole thing for you and get it to market with you.
Got it. That's great. It's quite interesting to see these take a physical form, and curious to know and curious to see what you'll build and where this goes in the future. Quite exciting. Sahil, same question to you again. Is there one place where you think voice agents will probably show up in the next few years that will genuinely surprise people?
I can see a world in which, as a consumer, there's a lot more proactive reach outs from organizations that otherwise wouldn't have the time. So, for example, one good example that I've heard is healthcare is almost always reactive. You don't have sort of people reaching out to you and saying, "Oh, this is a pollen event. Are you doing okay? Or have you taken your medicines this afternoon?" And so I can see a lot, and all of this was gated by sort of the cost of human labor. I can see a lot more situations in which we can be assisted. The service levels for the services that we need for health support that could go significantly up. I imagine that people will be surprised by how good some of these things can become.
Interesting. That's quite interesting. So we've this was the section on the future. We've reached the end of the questions that at least I wanted to ask and discuss with you. We are going to open the floor now for audience questions. I already see some questions in the Q&A tab, and I'll get to them one by one. But other members of the audience, if there are more questions, please keep adding there, and we'll answer them one by one. So the first question that we have is interesting, is more from a career perspective. It's from Balishwar. Again, apologies if I get your pronunciation wrong. But the question is for both of you. How do you see the future of voice agents for a 25-year-old tech professional? And should he focus on fundamentals and how to build voice agents, how they work, and tailoring them to specific use cases? Or leverage existing services offered by companies and learn how to integrate them into business needs and drive revenue growth? I think it's a question of which side of the business would you be on?
It's also a matter of opinion, right? But given the rate at which the market is disrupting itself, to be focused on the latter or the second one while continuing to dig in and learn the fundamentals of the first, might provide you with better overall career growth, right, and opportunities.
Got it. Got it. Sahil, anything to add to that?
My advice here would be to follow your interest. If I understood the question correctly, is it, should I be using the tech to solve real world problems, or should I be building core tech infrastructure? I think both, given how quickly this thing is going to evolve and how big it's going to grow, it will be large enough and interesting enough. There are different skill sets and different sort of types of work that you have to do, and depends on what you're interested in. If you're great at sort of working with people, drawing insights from them, learning that to build a great SOP, build great voice agents, then there's value in that. And if on the other side you want to sort of build great ML models which can do stuff that existing ML models can't do, and there'll be work for that as well. So a lot of it comes down to what is interesting to you.
Got it. Got it. Great. The next question that we have is, how do you test the voice agent before taking it live? And either of you could probably jump in and take that question.
Yeah, go ahead, Patrick, if you want to go first.
Sure. So I think one area is that we obviously have to optimize it for the specific use case and set everything up the way we intend for it to be used. In fact, we're working with a lot of ISVs, and we're actually, in addition to all the simulations and everything you can do, we still run test batches, right? And with internal tests, as well as with customers, to make sure that everything is up to their expectation before we will run a larger campaign, for example. So it's quite methodical. And then we also have ongoing black box testing in the background to make sure that your performance is still up to that expectation, and have your detailed observability tools to know ideally before something happens, but in the case something does happen, that we can really dig in quickly and resolve it.
Got it. Got it. Sahil, do you have anything to add there? Yeah.
Synthetic testing and real world testing. By synthetic testing, I mean building synthetic versions of customers that can interact with the voice agent, figuring out what the right success criteria should be, making sure that the synthetic version of making sure that the voice agent meets the bar with these synthetic customers, and then of course taking in front of actual customers and seeing if the expected metrics show up. I feel like this is an area in which tooling is still very much work in progress. I can see each of these things being its own sort of detailed, significant company, as it were. How do you simulate? How do you build observability tools? And there are a lot of people who are trying to do it. So yeah, I think it's still very much work in progress, and I think this is part of the infrastructure that still needs to be built to make it easier to deploy voice agents at scale. I still find that it's not hard. It's not hard in tech. It's not. There's still a fair amount of first principle problem solving that goes on, and there's no substitute for actually listening to what an agent is doing. You have to sort of test it, listen to it, and sort of talk to it. But I think the tools also could do a lot to simplify this process of testing agents.
Got it. I think to what you're saying, there's a follow-up question from Satyendra in the chat, which is, are there any automation tools? How do you automate this? Are there any automation tools you can use for testing voice agents?
So there are a number of different tools out there. We today are looking at tools from players like BlueJay and Azure to be able to perform in certain areas of this, and then also complementing that with our own tools. But yeah, there are a number of tools in this area available today.
Yeah,
got it.
From my perspective, I've tried a lot of stuff, and none of them are sufficiently far along that you can use it out of the box for a specific use case. So invariably, what we find is that for your use case, you actually have to do the work to design the judge, simulate, get the metrics outlined, and maybe there's no getting away from it. But there are some frameworks that can make it simpler. But the person building the agent has to do the thinking for the most part.
Got it. Understood.
And I would add, I'm sorry, I would add to that a little bit that there's also some of those tools also support the ability to simulate those different environmental conditions that I talked about to see how your agent actually performs under those types of conditions as well. So.
Got it. Got it. Great. I think the next question is why do AI voice systems still sound like a bot and people are hesitant in adopting those? They don't sound like humans. I think the essence is how do you make them sound more natural? Is there a way?
Yeah. Well, the first thing people have trouble with is the voice. And so, there's a lot of text-to-speech providers. You sort of got to sort through them and say which one meets my need, brand identity, whatnot. Uh, the second thing people often sort of reference when they talk about roboticness is that the agent doesn't breathe or it doesn't use disfluencies because humans don't talk like that. Those can be fixed by providing the right prompts to the LLM. You can say, use these 4 disfluencies, use them at some frequency. I think third thing people talk about is the agent sticks too much to script. So, if someone says, "Oh, I'm having a bad day. I'm sort of in a car crash," or something that would elicit human empathy, uh, you may find that the agent has been told to stick to a script and may not sort of respond. And so, I think those 3 layers are what we see. They all have fixes. You have to sort of iterate your way and find the service provider that meets the need.
Yes.
Yep, and yeah, I would say just to build on that. Also, it's depending on which regions, languages, providers, there are lots of combinations that can provide not so great results. So I think the key is you pick someone who's pretty proven in the space to work with to help you sort out those problems and deliver a better experience, because it can be done, or you can get much closer with the right combination of vendors and solutions and configuration.
Got it. Got it. I think there's an interesting follow-up question to this from Natasha, which is trying to compare how humans produce sound versus how AI does it, and hence, is there a challenge there? So the question goes: so despite the mass expansion in voice agents and training, the naturalness still doesn't seem to be wholly achievable. So, considering how we produce sound using our vocal cords, the role of the diaphragm, is it a case that this is not fundamentally replicable for voice agents?
I wouldn't say that. It's actually, I don't think it's about how we produce sound. It is about the meaning that is attached to a sentence. So let's take a simple example saying, "I'm here now." Now, you could say that angrily, "I'm here now." Or you could say that, in a jovial manner, saying, "Oh, I'm here now." Or you could say that as a sort of dismissive thing, saying, "Oh, I'm here now." Now, those 3 ways of saying the same sentence, the underlying meaning is very different. And the models are getting quite good at being able to say which of these 3 it should sort of sound like, but it's still not perfect. But ultimately, it's about if the model knows what the right meaning to attach to that sentence is, it'll produce it the right way. Just needs enough training examples and whatnot.
Got it. Got it. Patrick, do you have anything to add to that, which is how we as humans produce sound versus how voice agent does it?
Well, it's just only that you have to consider also the different medium over which an agent would be interacting with a human. But I agree with Sahil, right, that's the case. But for example, over the PSTN, it's narrowband, 3.4 kilohertz. In this case, the problems are actually different, where it's more about the understanding of the agent being able to understand the human under different conditions over that narrowband link, for example. But when you hear voice over narrowband, it doesn't really sound like the full range of a human voice either, because you're chopping that off just due to the technology. Right?
Got it. Got it. I hope that answers your question, Natasha. The next question that we have is so at the foundational stage, are voice agents optimized in English, then localized for specific languages? I think it's a pretty straightforward question. Yeah. Sahil, you want to take that?
Yeah. A lot of the ML models have disproportionately large training sets in English. A lot of the world's internet, a lot of the internet is in English. A lot of the audio and video that is available is in English. And so what tends to happen is that these models are lopsided. They'll have a large amount of English training data and then smaller amounts of other languages. How big that gap is depends on how much investment that the company has made in order to get proprietary data. But if you took publicly available data, it would be a massive difference. And so what that ends up happening is that these models are skewed in terms of their performance in English versus other languages. And so the way to improve it is to get the type of data that you need for both speech recognition, LLM, and text-to-speech. You have to add more of that type of data to the model so that it can sort of do better in the language that you want. And what that involves is you often have to go and get proprietary data because the publicly available data is simply not enough. You pick a small regional language in India, there's probably like a fraction of the amount of data that you would have available for English.
We did also find that in Japan, this is another market where the standard models weren't working for most customers, and so there are providers that have built custom models specific to that market based on data, in many cases private for certain customers as well.
Got it. Got it. Yes, that was the last question we had, I think, for the day from the audiences as well. Thanks a lot for your time, Patrick and Sahil, for joining in, for answering the questions, for being so open and honest about the real challenges that voice agents are facing today, for being simple and straightforward about your answers, and for making sure that you gave some solutions as well, as opposed to reiterating the same problems. That's the part I enjoyed most. So thank you again for joining in today. Big thank you to the audience for joining in, for staying till the end and asking, I think, probably a very engaging set of questions, and you were great. So thanks for that. This is for the audience. You'll receive the recording of the webinar on your registered mail ID. And this is where we come to the end of this webinar. Thanks, Patrick. Thanks, Sahil. Thank you, everyone. And stay tuned for our next webinar. This is Sundar from Murf AI, and we're signing off now. Thanks a lot.
Thank you, everyone.
Everyone.